Hey guys, I want to make a video on proportional reasoning. Mr. Mitchell has done this in a couple of our lectures. If you haven't been coming to meetings, you might be missing stuff. But anyway, I want to make my own video. I think he's going to make his own video, and so I wanted to address this. He did a really good job of it. I really appreciate him. He's a really smart guy, and he keeps me on my toes. So we have this equation here, A equals B times C. So we'll say this is A equals B times C. Right? And so let's say that A increases. All right. And let's say that we keep B constant. So B will be kept constant. So the question is, if A increases and B is kept constant, what happens to C? What happens is C will increase as well. The equal sign here is misunderstood. Equal signs mean that both sides are equivalent. Doesn't mean they're the same, because obviously A and B are not the same thing. On this left side we have A, and on the right side we have BC. What we're saying is that whatever A is equivalent to whatever B times C are. So in this case, if A goes up, then that means this whole side, this whole left side, increases in value, increases in magnitude, whatever you want to say there. Well, then this whole right side has to increase also. Okay. So if B stays constant, C will increase. Okay. We can look at something like this here. And Mr. Mitchell did this in our lecture, and I thought it was great. Here, we have A is equal to B over C, B divided by C. So if C increases, let's say B stays constant again. So we'll leave B constant in both of them. If C goes up, what's going to happen to A? What happens is A goes down. It will decrease. Okay. What's happening here is A is in the top of its fraction. A is really A divided by 1. Just like here, this is A over 1. This is B over 1. This is C divided by 1. Okay? So this is in the top of its fraction. This is in the bottom. These two things, what we say is, and this is fancy, is that they are inversely related. So if A goes down, C has to go up, or if C goes up, A has to go down, because they're in opposite sides of their respective fractions. So what we can do here is, because B is constant in both, it's a constant. It's like something, if you're doing a lab, you have to leave certain things constant because you're testing other things. And so B in both cases is constant. We can say that A is proportional to C. Whatever happens to A is going to happen to C. Okay. Here, A is proportional to 1 over C. So let's try something else. So we can do something else here. We can say, what if we multiply A by 2? We'll leave B constant. And what happens to C? It has to be multiplied by 2. Okay. Over here, if A is multiplied by 2, right, and we leave B constant, what has to happen? This one's a little harder. It's a little trickier. So what I'm really doing here is I'm multiplying this whole side by 2. Which would mean I'd multiply this entire side by 2 as well. B is a constant, so what we really have is A is equivalent to 1 over C. So we're going to multiply A by 2, which means we multiply 1 over C by 2 as well. Which really means this 2 ends up in the top of this fraction, right? And so what happens, since C is in the bottom of the fraction, this side goes down by a proportional amount to that side, right? We said that if C goes up, A would go down. What if A goes up? C goes down. And so here C is actually going to get smaller by a proportional amount, so you really have, 2A 2 over c, something like this. Another way to look at this is to say, what would I have to do on this right side to make this left side true, right? So what would I have to do here in order to make this 2a? What would I have to do here in order to get times 2 on this left side? Well, I'd have to take this right side and multiply by 2. I get 2 over c, right? In other words, I've taken this whole thing, multiplied by 2, and that would give me 2a here. Let me show you what I mean. And this is a little tricky. So let's say we have a equals c squared. Let's say, okay, well then we're going to multiply this left side by 2. Right? What happens to the right side? And this one's tricky. People will say, well, 2a would be proportional to 2c squared. And, it's not. Because when you have the square here and then you have a 2, you're going to take 2 and square it. So this side should be 4, right? It's tricky when you have an exponent. Here you don't. So if this whole side goes up by a factor of 2, this whole side goes up by a factor of 2. Same thing here, same thing here. This is a little different. And so Mitchell said something in one of our meetings I really liked. He said, the way he approaches this is he basically says, what do I have to have here in order for this to be true? Right? So what do I have to have on this side in order to get this side to multiply by 2? Right? So if I have c squared here, what would I have to do? So how can I get this 2? So some people tell me that, all right, you just put a 2 in front of the c squared, and then you're done. Now, the problem is, what's really going on here? We need to put some parentheses, and when I learned this made a world of difference. Take red, the parentheses. What we're really doing here is we're taking c, this is c being squared. So I put parentheses around my c. So the problem with this, when you just put a 2 in front of this, is you're actually doing 2 squared, which is 4. You end up with 4 here, and you need 2. What do I do on this side to make this true? Okay, that's the thing. So that's not going to give me 2, right? 2 squared is 4. So what do I need to do here is, how can I get 2? I put the square root of 2. If you type this in, if you take square root of 2 and you square it, you should get 2. Okay. So what happens is, if it's a equals c squared, then then this side, right, a is proportional to c squared. If I multiply a by 2, well, I'm going to have to multiply this side by square root of 2. That's what happens. Whew. All right, so there's this question that I put into a quiz, and I had some questions, and took me by surprise, to be honest. I forgot I put it in there. Mr. Mitchell had been putting some proportional reasoning questions in some of his stuff, and so I put one in there, and then I forgot about it. That just happens. So we have 2 cars. They both start from rest, have the same constant acceleration. When radar is used to measure the speed of each car, car A is found to be moving twice as fast as car B. So they have the same constant acceleration. Radar is used, and it's found that car A is now moving at twice the speed as car B. At that particular instant, so these cars were already moving, at that moment in time that this radar is used. So the way I see this is, there's a cop way down here, and he has one of his little radar guns, right? And these cars start from rest, and they start driving with the same constant acceleration. Okay. At some point, radar is used. Car A is found to be moving twice as fast as car B. Okay. Now, at that instant, car A has a displacement that is how many times as great as the displacement of car B? And the answer is 4. And so I was going to just show you how this works. All right, so they're asking us about displacement. Constant A, constant acceleration. Car A is found to be moving twice as fast as car B, right? So A is constant. Car A's velocity is 2 times that of car B, and they're asking us about displacement. Do they say anything about time? No, nothing about time. Okay, so these are the things that we know. We're talking about A, and if I make a chart, if I make my chart, right, we want to know something about displacement. A is constant. We have something about velocities just in general. Yeah, we know that the initial velocity was 0 and that these things they have certain speeds. So these are the things that we know. We don't know time, right? So if I look at my 3 equations, which one doesn't have time in it? Equation number 3 is the one that doesn't have time in it. And so this is what I can use to talk about this problem, to solve this. Now, for one thing, I'm going to take a look at this and try to decide what are the things that I don't need, what are the things that either drop off, go to 0, or are constant. They both start from rest, so my initial velocity is gone. For both cars, accelerations are constant. And this 2 is the same for both cars. So really, if I have this equation, I can do this twice, one for car A, one for car B. Those things are all constant, right? So what I can say here is that my velocity squared is proportional to the displacement, okay? So velocity of A is double the velocity of B. So I could say, well, my velocity of car A squared would be equal to the displacement of car A. Just say that, right? Velocity of A is double that of B. So instead of VA, I can put in here VB, double that of VB, right? So I'm replacing 2VB with VA. And I would square that, right? My VA is in my parentheses, and my squared is outside of it like that. Just like that. Okay. So what's going to happen here is I'm going to get 2 squared, which is 4. And I have 4 times the displacement for car A. I think that's the answer. Car A has a displacement that is 4 times as great as the displacement of car B. And this is a proportional reasoning thing. So I hope that makes sense. This will pop up from time to time throughout the year. We do something called Hooke's Law, K equals F over X. And so it's these 3 things. You can probably guess that F is force, X is displacement, K is something we haven't talked about yet. And so depending on what happens with F, X, or K, you can figure things out. So here, if F goes up, K goes up. If X goes up, K goes down. Okay. There's something else that we use, and it's called Ohm's law. I equals V over R. Current equals voltage over resistance. And here again, if voltage goes up, current goes up. Voltage goes down, current goes down. If R goes up, current goes down. So a lot of these relationships that we will talk about. I hope this one made sense as far as this question on that quiz goes.